All right, let's go through the schematic for this choo-choo train. um, it's pretty interesting. The nice thing about this is it's all analog circuitry. So a lot of people have asked for tutorials on analog circuitry and stuff. So yeah, let's go through this thing. So like I said before on looking at schematics, you try to figure out what you know and then concentrate then on what you don't know. So what do we know? Well, this is kind of a familiar thing. This is a push-pull amplifier here, and it's capacitively coupled out to the speaker that's referenced to ground. So I think with this we've seen before. And we've seen the bases tied together, and we know that that is a Class B amplifier and introduces a bunch of distortion. So we've seen some diodes put in here to try to offset that and stuff. Another trick you can do to get rid of that crossover distortion is to add this resistor. All right, so that's all this is here. This is just a buffer with some bleed resistor here to get rid of that crossover distortion so there's no dead band in there. And so this is our high current output, and that's being driven by this op amp here. Okay, so this is our audio amplifier, and we've got some feedback, and then here's the input. Okay, so this should all be familiar, right? So let's get rid of this stuff here. What doesn't look familiar is this stuff down here. So let's leave that till a little bit later. Okay. So, what is it that's coming in? Well, it's this thing here. This amplifier then is sending through our signal. All right. And well, what is it? It has something coming in on the plus, and then it has a feedback. It has a feedback here around to the input. All right. So this is just kind of a buffer. Okay. Some type of amplifier buffer. And whenever we see a non-inverting amplifier, there's a feedback resistor that then goes to ground. Okay. So this is a way to, you have a voltage divider here that acts as a amplification. So this is 100-to-1 amplification here. Now this is only operating though at AC. So it's amplifying at AC, but it's not amplifying at DC. So it acts as a unity buffer at DC, but it has a bunch of gain at AC. And it has variable gain at AC. It has it has one AC path here to ground, and then this particular part of the capacitor is also has some bleed resistor across it. I don't really want to go into that in this thing, but you can think of people talk about how many dB per octave or something amplification you have, and this just adds a straight section. So it's like a two stage amplification. It just has a different amplification for one and a different amplification for. I know that's a bad explanation, but anyway, it just adds ACD for this particular application. Just say this adds AC gain. Well, what is it amplifying? Well, it's amplifying something over here. So this is just a DC reference. So our input is biased at 4.5 volts. It's a 9-volt battery. So this is biased at 4.5 volts coming into pin 5. Because this op amp's operating from 0 to 5. So it has to be in its happy region. It has to be in the middle of that. So what is it amplifying? What is the source of this thing? Well, this is really weird transistor to ground. Okay. And it's not a typo. There's nothing connected to that collector. So it's just using the base emitter junction, and the base emitter junction is a nice little diode, and it is going to be our noise source. It's going to have a little bit of noise, and then we're going to amplify it and send it out. So this is kind of our noise generator. I did a video once on noise generation. It had a Zener diode to generate the noise. Typically, a lot of times they'll use a Zener diode. This is using a little base emitter diode. And it's a DC biased. It needs to be DC biased a little bit. So there's a DC bias path here. It's filtered also with this 10 microfarad capacitor. So anyway, so this is where we're getting the shh sound, right? This is generating the white noise. This is generating the shh. So the shh comes through here, gets amplified, and comes off the speaker. Now we want a ch. So we need something to go on, off, on, off, on, off, on, off. Well, how is that done? Okay, well, it's done over here. So this is the speed control. Okay, this is the volume control here. This sets how loud it's going to be. Okay, the feedback on our audio amplifier. And this is the speed control here on this particular circuit. Now, this particular circuit is going to act like a 555 timer. Remember how the 555 timer works? It has kind of a some hysteresis in it, and it goes up to it goes down to 1/3 and goes up to 2/3 and goes down to 1/3 and goes up to 2/3. Well, this thing sort of operates that way. We have the plus input here biased here, and we have 100K and 100K. So this point is at 4.5 volts. All right. So if this capacitor is ground, let's say it's shorted out, right? And the output of the op amp goes to +9, then +9 will come through here and it will start charging this capacitor. And that capacitor will charge up until it gets to 4.5 volts, and then this thing will swing, and then the output will then go to ground. And then we will start bringing in ground, and then we will start discharging the capacitor until it gets back down to 4.5 volts. And it'll go up and down and up and down and up and down and up and down. So that's what this is doing. And what does that up and down do? It comes in here into a transistor. And that transistor is just basically going to act like a switch, going to act like a relay. And it's going to change the gain of our audio amplifier. It'll be high gain and then a low gain, or maybe high gain then low gain. Yeah, I think this is high gain, right? We have if that transistor's on, then our feedback looks like this. Our AC feedback looks like that. So we have 5K with 100 ohms. So we have lots of gain. So this thing's going to be shh. And then if we turn off the transistor, then our feedback is here with 100K. So not much at all. So that's how it's being turned on and off and on and off and on and off. And that's what this thing does. So this sets the speed of the ch 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 ch, and this does the shh. And the only other thing that we have left over is the woo woo, which wasn't very good. It wasn't a very convincing woo. It was a dee dee dee. It was just a tone, and that's put in here with the whistle switch. And where's that whistle switch go? It goes into this thing. Well, if you look at this circuit and you look at that circuit, you'll find out that those are the same. So this is oscillating at a real low frequency, and this is operating at a really, really high frequency. And that's because of the values of the capacitors. This capacitor down here is 10 microfarad. This capacitor here is 3.9 nanofarads, right? It's pretty small. Anyway, so that's it. There's some additional little funniness going on. There's a little bit of injection here with this capacitor, and then there's a little bit of feedback here. So we've got this weird feedback path, and they're trying to get a better whistle sound. And they didn't do a great job, but they're trying. They're definitely trying. Talking about feedback, if I were redesigning the circuit, I'd say instead of having the feedback go to here, I would bring it all around to the front. And then you could get rid of the distortion that this thing causes. But hey, it's a train whistle, so maybe distortion's better. I don't know. Anyway, there you go. If you want to breadboard this or put it into Spice or something, there it is. Interesting little circuit, and it actually works pretty good, except for the whistle. Forget the stuff. Yeah, but the rest of it, yeah, it's pretty convincing. I like it.